So first of all, thank you for having me among you today and also yesterday. So it will be, I will talk about benchmark. I will do a little bit of advertisement to explain to you why we are doing hackathons, what's profit in doing this, to present a new tool. So let's talk about benchmark. Why do we always talk about benchmark? Why do we want this? Is it just kind of a TripAdvisor where we can let our hate just flow, or is there really a meaning for it? So just let's imagine that you are a data analyst, you arrive in single cell, and you are facing 1,500 methods. You don't know which one to choose, and so they are spread across 30 categories, and each one of them have their own benchmark. But each one of them will say, we have the best method for this purpose. So you would like to then go for a natural benchmark and see what's happening. The problem is if you, let's say, check a benchmark at this point, then it will miss the 500 other methods which arrived in the next month. And even if we decide to do a benchmark now, so at this point, it might be that in a few months it will be already a bit outdated, or that most of the methods that we benchmark, they are already updated in the next weeks. So we were thinking, so the first thing that we did was a little meta-analysis to try to understand what's happening with the benchmark. How is it that it's only a single snapshot? And we did a little meta-analysis of the benchmark in single cell. So there are 60 different benchmarks in single cell, only in single cell. And good thing, most of the data are available. Most of the code and data are available. But when we looked at the extensibility, we noticed that there are a lot of problems about, for instance, no containers which were given, or it's very hard to extend existing code, meaning that the way that we do benchmark is always reinventing the wheel. All of the benchmark that we know that we checked were basically building their own benchmark from scratch again and again, and it will be the case again in the future. So that's why we wanted to do benchmark in another way, and we thought about using another framework to do benchmark. That's why we came up with the idea of a continuous benchmark, so a benchmark where it would be continuously updated, where people could add their tools, data into it. And it's a collaboration that we have in the group, from the group of Mark Robinson, with the PhD student and postdoc, and the Swiss Data Science Center. So why did we involve the Swiss Data Center? Basically because we already use their platform, which is called Renku, to do some teaching. So basically Renku is a data analysis platform, which is meant to be fully reproducible and fully tracked. So that is, you can create a project on this Renku platform, and the project is automatically bundled with Jupyter or RStudio session. So you connect to the user interface, and you have some resources dedicated from their own server. You can also link it to your own server. And you have everything for reproducible research. So you have GitLFS, you have Git system, you have Dockers, you have common workflow language for workflow system. So everything is standardized, and you can choose to run your analysis, and every step in the analysis is tracked, the outputs are tracked, and the intermediate results too. So that's why we wanted to then build our new benchmarking platform, so that we don't have to start everything from scratch. So how does it look like? The 2 points that we wanted in the Omnibenchmark system is first, that meta developers and benchmarkers, they could bring their code and their data at any time and very easily. Second thing, we noticed that the problem in the benchmarks is that you have a snapshot. You have a snapshot of the evaluations, and you only have a figure, let's say, which presents the results. But what if you would like to dig a bit into these results? You would like to see how does it react to, let's say, PNC or mouse or another organism which is not well studied. Or what if you would like to see how it reacts to sample size? Then you are totally limited to the figure of the paper presenting the results. So what we wanted to do is to provide interactive visualization, because we don't believe in the black or white evaluations. We believe that you may have different requirements. Then in this interactive session in the form of a Shiny app. You can then play with the parameters, you can play with the evaluations to see what best fits you. So in a sense, the design of Omnibenchmark is not super complicated. I mean, it's on the user perspective, it's still layers of data, methods, and metrics, but all of the different pieces is like Lego pieces. Each one of these, what we call module, is separated. That is that you can work on, for instance, adding a new method. You work on this project, which is bundled with Docker image, Jupyter, and so on. You work on it, disconnected from the system. So for instance, you can work with templates, that is standardized repos, where you can then work on it, add your code, your data, or your methods. And then you can push it to one of the benchmark. It will get automatically validated, it's integrated, and as soon as we have something new, then it will rerun the benchmark again and push it to the Shiny app for the analysis. That is, it's continuously updated. We are not based on calls or changes, so at any time people can contribute to it, and people can also contribute to it synchronously. That is, you can have many people working on it on the data side or the methods or the metrics. So that is the perfect format that we found to try to train people was a hackathon, because many people can work at the same time on some of the modules. We have this easy mode of contributions where people can work on a little project and just push it. And we have flexible architecture. That is, here it's the minimal, it's the design, but you may have different layers. You can have different layers of pre-processing, and you can play with how the modules are connected. So we had 2 hackathons. I mean, it was mainly with people from our own lab, but also from people in labs which were collaborating with us, who were interested in the system. So we have 2 hackathons, one in September, one in December, one in Bern and one in Zurich. The first one was fully presential. The second one was hybrid. And the idea was to stress test and make some contributions to the existing benchmarks to see how it's going on. So the first stress test, so to say, was to populate a benchmark on clustering. And the idea of this first benchmark that we called Omni clustering was to produce an existing benchmark done in the lab by Duo, which was about evaluating clustering methods. So the idea was to port this benchmark to Omnibenchmark to see how it's going on, how it's working. And in the end, now we have this little representation where you have all of the modules connected and how they are connected. You see that it's a bit complicated in the middle, but basically how they are connected into the system. Straight after this, we have another Omnibenchmark, which was initiated by Helena in our group and now continued by visiting students, Soren, which was about spatial clustering. So how to, which was basically a benchmark about the clustering of spatial data. So here we have a bit more complex architecture. You can see that we have a lot of different layers of processing steps. So basically at the left-hand side, you see the 2 datasets, which are then passed to many other processing modules into the benchmark. With the idea that now we can benchmark how spatial mixed data are clustered. So the strategy of these hackathons. So the idea is that we had, of course, first introduction to the idea from the benchmark. So a bit more details into this meta-analysis that we did. So then the technical details, so how it's working under the hood. I mean, now I'll give you a very brief presentation, but there are many features inside of it which control how modules are added, how they are connected. So we wanted to give this little insight to participants and how to contribute to it. That is, how to work with these templates, how does it look like, which code you have to bring, and so on. Then the group work, so people were basically split among different benchmarks, and then they could, at the same time, very same time, contribute to data sets or methods or metrics. And then we were there to bring some hotfixes in during the run and also some guidance. But the idea is that we also gave a lot of different documentation for them. So we had step-by-step guides on how to add a new benchmark. We have our own website. We have the PyPy module, which connects the users to the system, and read the docs. So overall, it worked quite well. I mean, we populated these 3 benchmarks, and now they are running and functioning very well. Still, hackathons are not that easy. One main problem is a problem which is a bit like the egg or chicken problem. That is, we gave some technical presentations about how to use a new system, but at the same time, as soon as we dig a bit into the code, people were a bit lost because they didn't have this feeling on how the code was working. But then at the same time, if you first start with hands-on experience, then people don't know how to react and how to use the tool. So it's still a big question from our side how to deal with these 2 aspects. Then many resources, maybe too many resources. But I mean, it was also resources which were a bit separated. I mean, there was a step-by-step guide that we cannot really put on PyPy, and the PyPy module was about really the technical aspects. So we have to have different types of resources, but it's still hard to see how we can provide it to users. We can try to centralize everything, but still it's a lot of back and forth between everything. And finally, the one challenge was to adapt in live. I mean, the needs to different levels of other skills, because we had some bioinformaticians. We also had computer scientists who didn't know what a single cell object was. So we had to deal with all of this. And sometimes it's a bit hard to either focus on the technical side, so how to deal with the Python code and to interact with the framework. And sometimes to explain the basics of the benchmarks, because I guess each benchmark has its own specificities, and you have to have a bit of knowledge about this. So it was the final program. But overall, yeah, I mean, now we are open to new hackathons. We'll give a workshop at the VC2 conference in Basel. But the idea, as I said, is that we are not based on calls or changes. It's totally open, and that I think we will continue with this idea of hackathons because it worked well in this way.